how do we use Python? We are this, right? So you are here sitting at a desk, kind of just desk sitting. We type in Spider, kind of on the story. IPython interactive computing is what allows us to go back and forth with the Python language. Everything then gets soaked through Python, which then goes down to a CPython and gets executed on hardware. We then use matrices that come from NumPy. We use Matplotlib for plotting. We use SciPy for signal processing. And then we hope to end up here, which is our sklearn for machine learning, right? Took us a little bit, but this is kind of our equivalent Matlab. That makes sense? Just the way that we do it, or one way to do it. So let's talk about these a little bit in detail. NumPy, numerical Python. Python does not support arrays and matrices, and its mathematical support is limited and slow. So NumPy was created to add support for arrays and matrices. NumPy adds support for high-level mathematical functions to operate on arrays and matrices. The documentation can be found there. It's limited in scope and only designed to add additional numerical computing to Python. You will find some things that are in NumPy and in SciPy, and you'll be like, oh, I can do an FFT in either. But then once you start to play around with it, you'll realize the NumPy one is just very much focused on a specific algorithm, while the SciPy one might have more bells and whistles and accoutrements to actually help make it usable. NumPy underpins nearly every scientific computing platform created for Python. It's everywhere. Matplotlib is a plotting library. At one point, it was formed by combining multiple libraries, PyPlot, PyLab. We'll use PyPlot. PyLab's use is discouraged. That's kind of the non-MATLAB-based one. PyPlot is a Matplotlib module that provides a MATLAB-like interface. Documentation can be found there. PyPlot documentation can be found there. You can do radar plots, 3D plots, line plots, all sorts of kind of cool plotting and interfaces. SciPy, not to be confused with scientific Python, which is a completely different program, which is no longer used or no longer supported, is a Python library used for scientific computing and technical computing. Builds on NumPy array class and the capabilities of Matplotlib. Contains modules for optimization, linear algebra, integration, interpolation, special functions, FFT, image processing, ordinary differential equation solvers, and other tasks common in scientific computing. SciPy and NumPy contain duplicate capabilities, right? Like the FFT, a common way is that NumPy version is more bare bones. And so SciPy, you can do interpolation, you can do like filtering on figures, things of that nature. Scikit-learn, also called sklearn, is a machine learning library. Kind of does various classification, regression, clustering, including support for vector machines, random forest, gradient boosting, k-means. Designed to interoperate with Python and numerical libraries. Documentation can be found here. It's starting to level out, right? So 4 or 5 years ago, it was pretty new, lots of changes, but every year that goes by, there's less and less changes to it. So it's really starting to kind of become a very mature program, which is nice. Conclusions, Python is great, but not useful for scientific computing. So we add scientific modules that have been developed on top of that to make it useful for what we need. And then we need a way to interact with it. And so, at least in this class, we're just going to use Spider because it gives us a variable explorer.